Namaste, welcome back to the Pragna channel, and you are watching AWS real-time cloud projects for beginner to expert levels. And we are in season 6, which is a networking role. And so far, I think we have finished, I think, 5 projects. Today, we are going to do our project number 69. And just to uh, not review, but total projects we have is 94, and we are at project number 69. And in this season, as network in the networking role, we will do till project 79, and after that it will be part of the final season, which is the machine learning. So let's finish this one, and today we are going to see, or not see, we are going to do our project number 69, which is egress traffic filtering. So let's go. And okay, yeah, this is fast, this space flight that we got, I think, in the first project we did here. We got this one. So let's go and learn about this project more. Hello, I need help to support a secret mission. Sounds interesting. What is the secret mission about? I need to restrict access to satellite data to authorized users, and the data should only come from expected network locations. Okay, okay. What concerns do you have related to this data? We're concerned that the data could be compromised and the mission leaked to the public. What is the mission about? A robotic spacecraft sends detailed images related to the moon's surface to a research station. These images are used to prepare future human and robotic missions to the moon. This spacecraft is required to communicate with only a few approved domain names owned by the research station. So, egress traffic to unapproved domain names should not be allowed. Is that correct? Yes, that's exactly what I'm looking for. Great. I think AWS Network Firewall can address your issue. You can create domain-based rules and protocol-based rules. These rules can then be attached to a firewall policy, which is attached to network firewall. Finally, you would configure your VPCs to route traffic through the firewall endpoints to control traffic. Looks like AWS Network Firewall can solve the problem. Can you demonstrate how network firewall can filter outbound traffic? Sure. Awesome. Can't wait to see the demonstration. Didn't we do something similar but using what was it? I think maybe not the previous project, but the one before it. I think it's something called domain list and etc. Right? I think it is the same. I don't know. We'll see. So by the end of this project, we will learn how to create network firewall rule group, and a firewall policy, and we will update route tables with firewall endpoints. Let's click start. Let's go to the video concepts, and if you haven't already watched these ones, I would recommend you to go ahead and watch them. Even if you watched them previously, just watch them again so that you can revise whatever you watched long time ago. And these videos are available in the playlist that will pop here. Once you click on it, it will take you to AWS tutorials for beginners playlist. Search with these video titles and watch all of them, and come back and watch the remaining project. Okay, so let's go through our mapping. Looks like there are 16 steps. Wow. This solution demonstrates how to use AWS network firewall policies to filter outbound web traffic. Lab VPC A, VPC B are workload VPCs in different availability zones with no internet connectivity. As you can see, all are private subnets or no internet connectivity. Lab VPC Egress consists of VPC, sorry, three subnets, 1, 2, 3, in each availability zone. And VPC has internet connectivity. As you can see, there are two public subnets, which means you have internet connectivity. AWS Transit Gateway acts as a highly scalable cloud router, a network hub that simplifies the connectivity between VPCs. Each new connection is made only once. We have already done something similar to this one. AWS Network Firewall, as you can see here, is a managed service that helps deploy essential protections for all network VPCs. Network Firewall supports inbound and outbound web filtering for unencrypted web traffic. For encrypted web traffic server name indication is used for blocking access to specific sites. I think we have done something like this in one of the projects. Network firewall covers east-west traffic filtering, which is called inter-VPC inspection, and north-south traffic inspection and filtering, which is called internet traffic filtering. Network firewall covers east to west traffic filtering. Okay, I don't know what this means. Inter-VPC inspection. Okay. And north-south inspection, traffic inspection and filtering, which is called internet traffic filtering. Okay. East-west means within, north-south means internet traffic. Okay. That is something new. And VPC A and B are attached with transit gateway for all east-west or north-south communication. Okay, yeah, I think so. The default route in the VPC route tables, wherever that is, I think here, to in the default route towards transit gateway ensures that any traffic exiting VPC A and B goes to VPC egress. Okay, exiting from this will go through this one. Okay, transit gateway contains two route tables, which are shown here. One route table associate AB, which you can see, and the other associate egress. So anything that goes out from here will go through this one, which is why the target is VPC egress transit gateway attachment. And then another route table which has this one, both pointing to the VPC A and VPC B, I guess, within this one, lab VPC. Okay, no, lab VPC A is this, lab VPC is this. Okay. Network firewall supports different types of rule groups. Domain list rule groups allow traffic to only the listed domains. Port-based rule groups can also be defined. I think we did something similar. A network firewall policy is created with either stateful or stateless rule groups to associate it with a firewall. Firewall endpoints are created for each availability zone listed in the firewall configuration. An endpoint is associated to a firewall subnet. After the firewall endpoint is deployed and available, all route tables in availability zone A are configured to allow connectivity to the internet, which you can see here. Firewall rule group connectivity is tested by using Amazon EC2 instance deployed in lab VPC A. For high availability, all the route tables associated with availability zone B should be configured. Connectivity can be tested by using EC2 instance deployed in VPC B. Firewall endpoint A, firewall endpoint B. Okay. I think pretty much that's it. I know there is a lot of information here. Even um, some parts are missing even from me. I mean, they are there, but grasping, I am unable to grasp it. So maybe once we go through the labs, maybe we'll understand. At least I will understand. Maybe you already understood what they are saying, but for me, no, it's not registering. So let's see. We will review the EC2 instances and its details. We will create AWS network firewall policy and rule groups, and then we verify connectivity of the network firewall rule groups on the EC2 instances. Then we will update the domain rule group to allow connectivity. Then we will review firewall logs on Amazon CloudWatch. As part of DIY, we are going to update the route tables for lab VPC B, lab VPC egress to allow default routes to the transit gateway. Add a route for the lab VPC B CIDR block in the firewall route table. Verify connectivity on the EC2 instance in lab VPC B. Okay, that is too much information, and I am not sure um, if I will be able to successfully do this. Wish me luck. Maybe not luck, but I hope I will. By the end of this project, I hope I will understand what is happening here. Okay, let's click on Start Lab. There are no files to download, and read through the concepts. Oh wow, there are 71 steps. Okay, this is this is going to be a goner for me. So let's go to the VPC first. Obviously, everything is around VPC in here, and then let's review them and copy their respective CIDRs, I guess. Okay, these are the VPCs. We have three VPCs as they mentioned. Okay, we'll copy all the CIDRs of these three VPCs, and then we are going to go to the transit gateway, choose that, and then review that it is available. That's it. So let's go here and read through this because I need to understand what's going on. AWS Transit Gateway provides a hub and spoke design for connecting VPCs and on-premises networks as a fully managed service without requiring you to provision virtual appliances like the Cisco CSRs. No VPN overlay is required, and AWS manages high availability and scalability. Spoke VPCs have no direct internet connectivity, and they are attached with transit gateway for all east-west or north-south communication. The default route, all zeros in the VPC route tables towards the transit gateway ensures that any traffic exiting a spoke VPC goes to the egress VPC. So they are talking spoke VPC means VPC A and B. Okay, then we are going to go to the transit gateway attachments. When you attach a VPC to a transit gateway, you must specify one subnet from each availability zone to be used by the transit gateway to route traffic. Specifying one subnet from an availability zone enables traffic to reach resources in every subnet in that availability zone. Okay, which is good. And okay, we will just review the attachment that they created, which is VPC A transit gateway attachment, B transit gateway. I think we did create these in one of the project. And let's click each one of those and review that they are enabled. Enabling appliance mode ensures that the transit gateway continues to use the same availability zone for the VPC attachment over the lifetime of a flow of traffic between source and destination. Okay. And then we will go to the EC2 instance, and then we will log in into the VPC A just to check the connectivity if it is working or not. All right, and you can see this has the lab VPC A. Let's click connect, and then we'll go to session manager and connect. Once we are in there, let's execute this call command. Okay, once you execute this, you can see it timed out because remember VPC A and B don't have internet connectivity. They only have private subnets, so they cannot talk to public internet. So which means this is working as expected. And let's go to the security and click on the VPC A workload subnet security group. Okay, so there are what? Two security groups. This is lab stack, doesn't matter. I think VPC A security group. And if you see this one has where it says all traffic all source from there. This instance allows traffic only from this CIDR block range. You will create firewall rule groups with this IP CIDR range as the source IP. The VPC egress CIDR block is 0000/16. Okay, go to the next step. 16 is less than 8. I think 16 will have how many? 65,000 or something. 8, imagine double than that. So yeah, obviously this is going to have more, maybe 256K or something. I don't remember. But anyways, you can click on the inbound rules and that. Okay, let's go to the okay. Then we are going to go to the network firewall rule groups. And then we are going to create rule group. And it's going to be stateful. And it's domain list. I don't think we created this one. Action order. Click next. And the name we are going to give this is domain rule. And capacity is 100. the number of rules we expect to have in this group, because this is just a group, so we can have up to 100 rules in this one. The limit is, I guess, 30,000. And which ones are we giving? These two domains. We created domain list previously in one of the, I remember, where we blocked network from Google, and we are going to give this one as the Cedar block custom. The source traffic Cedar ranges to inspect. Okay, create the rule group, and we are going to click another rule group, and again it's going to be stateful, but the rule group format here, it is going to be, instead of domain list, this is going to be standard stateful rule, and it is going to be action order. Rules with pass action are protected first. We'll go through that, and we will name this ICMP rule. And capacity again 100. I don't think we are going to create 100 rules, but, and protocol is going to be ICMP. Let me go back. What did we choose for the other one? Okay, we just selected domain names because it is a different one. Okay, and the source is going to be custom, and IP at Cedar block is going to be same, and everything is default. Okay, we still have more. So traffic direction forward, action, pass, then we will add rule. Create role group. Did we add role? Click that. Okay, then it added this one, I guess. Any for that one with that protocol. Now let's go to firewall policies and create firewall policy. We created roles. I think firewall policy is going to use these rules, rule groups at least. Drop. We will go through what this option means. Next, use same actions, and that is the fragmented packets. Choose how to treat fragmented packets, and then we have rule action. Choose how to handle a packet that matches the rules we want to forward to stateful rule groups, and we are going to select the rule group. Action order, and then add stateful rule group, and we are going to select both of them. Okay, click next, 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 create the firewall. Okay, once that is done, we are going to create network. What is it? We are going to create another, oh, not policy, but we are going to create network firewall, and we are going to name it network firewall. Next, and configure VPCs and subnets. The VPC we are going to choose is the Egress one. Availability zone, since we have two, we are going to pick both 1A, and then we are going to choose subnet IPv4 IPv4. What do you mean by? So these are the firewall subnets. Okay, okay, Next, and clear both enable, and then click next. Associate an existing firewall policy, and then we are going to pick the firewall policy that we created. So we are coming the other way around. Instead of creating a firewall, then firewall policy, then firewall groups, we created the groups, then the policy, and then the firewall, then create firewall. Okay, it's provisioning. I think it will take some time. That's fine. And these are ready. Okay, we need to copy the endpoints. So once that is done, we can go to firewall endpoint section, copy IDs. Okay, now you can see the firewall rules policy and the domain, the groups, etc. You can see all them in the sync, and then click on logging, edit. What are we going to do with the logging? We are going to have both the alert and flow, and obviously CloudWatch log group we are going to pick slash AWS slash FW, which is the firewall alert. Okay, which is good. Next. Okay, what is this one? Log type, log destination, we pick that one. Okay, that is again log destination for flows. For flows again, CloudWatch log group, and then this time it is going to be AWS slash that flow. Okay, this is another log group that we are going to use. Okay, that's all done. Now we are going to the route tables. Okay. Okay, in the route tables, search for VPCA workload subnet, because we have another one transit gateway subnet as well. We are going to select lab VPCA workload subnet, then routes on it, and then edit. Okay, we are going to type all zeros and then VPCA transit gateway attachment. We have, I don't know, I think maybe it is going to be, we were going to do this in the next project, I guess, but we have done something similar. I don't remember, because the next project I actually recorded it first by mistake. So okay, that is one route. We are going to add another route. So technically what we are saying, the VPCA workload out destination, when the traffic flows out, send it to the VPCA attachment, that attachment. Okay, then we are going to add another route. Oh, are we? No, I think that's it. We already added it. Now we are going to go to the VPC lab VPC egress subnet A, and same thing, routes, edit. Okay, here let's copy this IP address, because that is important. If you mess up IP addresses, then it is gone. Okay, so here we are going to select that one, saying send it to this one route. Okay, this is already there. Destination is this, and then target is going to be the transit gateway egress attachment. For another destination route in the egress firewall subnet table, you will add the source IP CDR range that the EC2 instances security groups allow traffic to. Once that is done, we will repeat the same thing again for public subnet. So previously we have used firewall subnet, right? Let me go and check that back again. Yeah, that's firewall subnet. Okay, now we are going to do that for egress public subnet A. Okay, routes, edit, and this time, oh, paste. Where did we get this? Initially we copied some, right? I think maybe that's what they're asking us to paste. Let's see. You are adding a route with a firewall endpoint as the target to the subnet in the east one. Destination is going to be the same IP address, but the target is different. For target, paste the firewall endpoint ID for US East 1A that you copied in earlier step. Interesting. Firewall endpoint ID East 1A. Because this is for public subnet A, we are going to pick its respective A. You must add a similar route to public subnet B. Okay. Yeah. And we are pointing it to the endpoint B. Okay. Firewall endpoint. Okay. Makes sense. By adding a route with a network firewall endpoint in the Egress VPC, you can ensure that all outgoing traffic from your VPC is filtered and inspected by the firewall. Okay. Okay. So anything that comes here has to go through this firewall and inspected by that one. Okay, makes sense. And we are going to do that for the transit gateway as well. Egress transit gateway subnet A and routes edit. Okay, here we are going to put all this, and the target would be, what is it? Target endpoint of that you copied in the earlier step. What are we doing here? You are adding a default route with the firewall endpoint as the target to the route table. Firewall endpoints are zonal. Be sure to paste the correct zonal VPC ID. Okay, the default route. Okay, we are putting here the default route for the transit gateway route is this one. Okay, I hope I understand. Okay, once we do all this, let's go to the, no wonder why it has 71 steps. Transit gateway route tables. And we are going to select transit gateway route table and then routes, create static route. When a static route and a propagated route have the same destination, the static route has a higher priority. Okay. Then we are going to type all zeros and active. Yeah, this we created in one of the projects wherein we pick the type black holes so that we blocked network traffic from a particular CIDR. Okay, here we are going to active, so we are going to give it. Then we are going to choose transit gateway firewall route table, and same thing, routes, create static route. Okay, so we have separate route table for firewall for the normal one. Okay, so for the normal one, we said all default active, do that, and this one has coming from only that, and this will be pointed to VPCA TGW. So previous one was the attachment is what? The egress, here VPCA, and I'm assuming this is the seeder block of the VPCA. The statics routes traffic to the transit gateway attachment. Technical, I think that's what it does. You are creating a static route for the VPCA seeder block with the VPCA transit gateway attachment. I think technically that's what we are doing. You must create a similar one for lab VPC fee. Okay, now let's connect and test the connectivity again. Okay, I think are we connecting to the same thing instance? Yes. So this time this should work. Okay, previously it didn't work. The entries for the route table, the route traffic that has been processed by the AWS network firewall current is flowing out of the to the final destination. Okay, now you can also type the curl this one and it will time out for the Google. Why? Because we only allowed it for Amazon. So when you do that, it is saying trying and that because the call command comes out without returning because we only allowed the egress traffic to the domains that we actually put in the domains list. So if we can go back to domain rule and maybe we can edit it and add it. Edit, see, edit it, add dot google.com, and we don't have to repeat all the steps since we already have everything set up. We can go back to this and run that command and it will run successfully. Okay, now if you ping this one, what is this one? 111111. Now you will test the ICMP rule to see if it can reach a destination with IP address that one. But what is all ones? Okay, we can go to the log groups alert. Log stream, open it, and you can review all that alert. Source IP address not matching any TLS allowed list FQDNs blocked because 11111 is doesn't match any of the seeder blocks that we defined. And we can go to the firewall and you can see all the details here for the firewall as well. Source IP is that. I think pretty much that's it. And you guys might be sitting there and be like, zero information went into the head. It's just showing couple of steps, but nothing went into the head. It is asking us to create go to VPN, this route, egress route, huh? Transit gateway route. What the hell is going on, right? I know. I feel you. I feel you. I don't understand most of it, but let's hope that while we do it, by the way, we only finish these steps. We need to repeat these steps now. And too many things. I don't know if I will be able to successfully do it, but let's do it, right? And while we do it, let's try to understand it. If we don't understand this, that's fine. We still have 10 more projects to go in this one. Maybe by the time we finish them, we will get used to this one, right? I mean, if you're already a networking person, you can leave a comment explaining us what's exactly going on, maybe in a, easy way, not whatever they are showing here. Okay, are you all ready? Because I'm not ready. Okay, let's open this. Do we even remember where we started? It's a long, long time ago. Okay, so let's go to our VPC. Okay, let's click on the VPCs. So let's click, we don't have to click. Okay, let's copy this one, consider this is for the VPC A, VPC B, and then this is for the egress. All right, so we already know 16 means it will have a range of what, 65,000 IP addresses. For this VPC you can have that. Same thing goes with this, but these all start with 000. This all start with 200, etc. Okay, now as you know, this 0 can go up to 255. So I think that's what, when you multiply, I guess you will get that one. Anyways, so what do we have to do next one? We will go scroll down. We will review everything right now. The transit gateways, here we go. So there is already transit gateway created. As you already know, this is a central hub, right? What does this do? It will make those VPCs talk to each other. How many VPCs we have right now? We have VPC A, VPC C, and egress VPC, right? So it will make all these three VPCs talk to each other, connecting to each other through this gateway. So once you create this gateway, you have to create attachments. Through these attachments, you will make them talk to each other. Okay. So um, since all of them are in the same account, then that is fine. You don't have to worry about it. But you have to create these attachments so that they can actually talk to each other through this transit gateway. So we have all this, all are associated. You can see association state. We have created transit gateway attachments in a couple of projects. In the next project as well, we will. Okay, nice. Okay, did we already select this one? And association route table ID. Okay, this is associated and etc. Okay, appliance mode, for this one it is disabled, but for this one I think it should be enabled. Okay, next, once we review that, what are we supposed to do? We will go to EC2 so that we can test that if we are able to connect to. Okay, let me go. I think we still have windows from the previous ones. Okay, we are on the EC2. Click on this. Let's click on the A, and let's connect session manager. All we have to do is run this command. This will try to run or connect it to the Amazon. But since the VPC A is in private, it cannot connect to public internet, so it cannot ping it. Okay, so let's go back. Select this, security, scroll down, security groups. This is lab stack. Where is the other security group? Okay. I don't know why this is okay, lab stack. No, it's not lab stack. That's not what I'm looking for. There should be another security group here. Am I missing something? I mean, when they showed us, there were two security groups for them. One of them was the lab stack. Another one was, oh, I think this is the one they're talking about. And they are allowing everything, and they wanted us to copy this one. Yeah, this is 10.0.0.0.8. Okay. Okay, so we made sure that it is not working as expected. So now let's go to the VPC, and we are going to go for firewalls, network firewalls. So if we want to create this, we need policies. If we need policies, we need groups. So let's go ahead and from bottom up approach. Let's create the groups first. So let's create a rule group. Let's cancel back. Let me see something first. It is a reusable set of firewall rules for inspecting and filtering network traffic. You can use stateless or stateful rule groups to configure the traffic inspection criteria for your firewall policies. You can create your own rule groups, or you can use rule groups that are managed. So we are not going to use managed, we are going to use rule groups. Stateful to inspect packets within the context of the traffic flow. Stateless rule groups to inspect individual packets on their own without the context of the traffic flow. And a rule group format, we are going to select the domain list, and this is going to be the action. Next, and let's name this one, and let's name this domain rule, and let's give 100 the capacity for the rules in that particular rule. Domain names, we are going to add the Amazon, both Amazon AWS and Amazon, and let's click custom. And the cedar black, remember what we copied for the security group, it is 8, because this gives a wide range than 16. Okay, so I think these are fine. Let's click next. We don't want to change anything. Next, create the rule group. Okay, that is fine. Now let's create another rule group. Again, this is going to be stateful, but this time we are going to select standard stateful rule and action, and this is going to be ICMP protocol. This is for the ICMP protocol. The other one is just domain. So both we are going to create. And IP sets ICMP. This is optional. Okay, I was like, that's not what they showed us. Okay, and I don't think, is it source or destination? I think source, it's custom, and we are going to select this one. I think source port, any port doesn't matter, destination any, forward, and it's going to be pass, and we'll click add role. So this role is added, ICMP forward pass SID1 on that one. Okay, click next, same thing, next, create group. Okay, so now we have two groups. One is ICMP and another one is domain. Now let's go ahead and add this group to the policy. So let's go ahead and create the policy. Firewall policies. Now let's create the firewall policy and let's name this that. And it's going to be drop all subsequent traffic going to the firewall. Okay. Whatever this policy meets, drop all subsequent traffic. And we are going to use the same actions for all packets, and we are going to forward to stateful rule groups, and we are going to add, sorry, this is stateless rule group, right? Let's scroll down, and action order, there should be something that says, yeah, forward to, okay, action order, add stateful rule groups. Let's select both of them, add groups, next, and we don't add anything, next, I think pretty much that's it, create. Okay, we have the firewall rules policy now. Okay, once we have it, now we can go ahead and create the firewall. Okay, let's name this firewall network firewall. If I go back, okay, what does this is a stateful managed network firewall and intrusion prevention detection service that allows customers to filter traffic at the perimeter of their VPC. Right before going inside itself, it will stop it. Okay, we are going to choose which VPC, the Egress, and we are going to choose the both availability zones or subnets, and the subnets we are going to choose are Mm, so which one did they choose? Firewall subnets. Obviously, I think it will be subnet A, firewall subnet B, and this one is IPv4. IPv4. Let me correct it before we finish everything and then doing it wrong. Okay, here we go. I mean, I cannot see this here. Okay, let's see. They will talk about here. Choose, yeah, egress firewall subnet. Yeah, okay, that's correct. Where you want protection. I mean, since egress only has public, that's where we want protection, right? That's why we are choosing egress. Provide network firewall with the public subnets that's dedicated to the firewall endpoint. Only use the firewall subnets that is specified here for the firewall. Do not use them for any other purpose. Okay, that's I think for that reason they created separate subnets for the firewall. Okay, let's disable this, delete protection, subnet change protection. Next, create and associate an empty firewall. No, we already have it. So let's select associate and let's select the policy that we have. Next, next, create firewall. So far what we are doing is just creating the firewall, and that firewall based on domain list and the ICMP, it will stop the traffic, right? So that's what we did. It is provisioning. By the time it is provisioning, let's go to firewall endpoints. I think where can I see the endpoints from? Will they show up here? I think they will show up here. So let it provision it. I will come back. All right, our firewall is ready, and we have our endpoints here for both our what are those called? Availability zones. Okay. All right. Awesome. Now, since that is done, the firewall part is done. Okay. So far, all we are doing is setting up that firewall. Okay. So let's go to the endpoints. We copied that. Now let's go enable the logging, and we should find them somewhere here. Edit it, and I want both alert and flow, and we are going to send it to CloudWatch instead of S3, and I want it to be sent to alert log to this one and the flow log to this one. Okay, save it. Good. Okay, that's all done now. Nice. Okay, okay, cool. Now let's go to the route tables. Okay, and you will see a lot of route tables here. Let me sort this on like this one. So let me go to the workload subnet. There are will be you will see two subnets whenever you see the transit gateway. But here we are talking about the transit gateway subnets. We are not configuring that. We are configuring the workload subnet of VPC-A. Okay, and let's go to routes, edit routes. You already have one, but we are not going to touch that. Instead, we are going to create another route with all zeros, and we are going to go to transit gateway, and there will be only one transit gateway attached. So we are attaching our routes to the transit gateways here. Basically, that's what we are doing. Okay, good. Now let's go back, and we are going to now pick the egress firewall subnet A. Remember we used this, we didn't use the route table, but yeah, this is the firewall subnet A. Let's go to routes. Let's click edit. You already see there are two of them. This is for the public to connect it to the public internet from within the uh, subnet. So that's what you are using, or the EC2 instance. You use a NAT gateway. We already know that, but we are not going to touch it. So what we are going to do for this firewall is we are going to add a route. Okay, it's not here. So let's go ahead and copy ours. Okay, and we are going to go here again, transit gateway. We are going to pick the VPC Egress transit gateway. So anything that is going out of this or going this should go to the transit gateway. So let's click save changes. Okay, so this is the firewall subnet A. I think firewall subnet B, we have to configure it as part of DIY. At least that's what I'm assuming. So, and once that is done, then we are going to go to the this one, public subnet A, routes, edit it. Same thing, this one has internet gateway, right? The previous one is a private subnet, that's why it doesn't have internet gateway. Instead it have NAT gateway. But this is a public subnet, so it has internet gateway. So to and fro you can talk to the public internet. Okay, this one same thing again. We are going to anything coming that way, we are going to send it to VPC Egress transit gateway. Okay, we're just sending the traffic from both subnets, the private subnet and the public subnet, to the transit gateway. In case if it is traffic that should go into the VPC and VPCB, right? So that's why. Okay, so far we did that. We did both of that. Route tables done. Okay, then what are we doing? Let's go to okay. I don't think the public subnet A is going to go to this one. Oh, what the transit gateway? I don't think it is for this one. So let's close this one. If I remember correctly, this is public, right? So public cannot enter the cannot talk to the transit gateway because this is all in the private ones. So in order to do that, I think we have to choose the VPC endpoint for A, because what do we use endpoints for? We use endpoints to talk to a privately, like in a private connection. If you want to talk to a private connection, we use endpoints. So I think for the this one we have to use the endpoint that we copied previously, and we copied two of them, and we should be make sure to paste the gateway load balancer endpoint. No, that is not gateway load balancer endpoint. um, okay, it doesn't have any option. Okay, let's go and check what they did. Edit route target, they entered it like that. Why can't I do the same thing? Why do I have to give this drop down list? Okay, let me click remove, add. Okay, I cannot do that, huh? I cannot do that. Remove this. No, I cannot do the local. Okay, if I put this one, oh, it is changing that to gateway load balancer endpoint. I don't know why it is saying that. So the thing is, these guys don't have something like that. When they created the lab, I guess it didn't update it, but for me it is doing that. That's fine. Okay, I'm going to put that. The reason we are not using the transit gateway is because this is a public subnet. So let's click save changes. Oh, it is not. Okay, what is it not allowing me to do? Delete route. What am I deleting? Okay, let me go back. Routes. I think, okay, maybe this one. Okay, let me select this one. Nope, not this one. Let me copy my this one endpoint, put it there. It's okay. If it thinks that's the one, that's fine. I don't mind. Okay, so we have that. Same thing, let's go ahead and do it for the other public. And let me copy its respective endpoint as well. Okay. I think they start with that. I guess that's why it is showing that one. That's okay. Okay, let's save it. Okay, so that is configured as well. Nice. Now let's go back and we are left with two more subnets, which is Egress Transit Gateway Subnet A. We configured for this one, all this. So now let's go and do it for this one. Route tables, edit it. Okay, we already have this local. Let's go and say everything that comes to this one. Let's go ahead and select. Okay, hold on. Uh, okay, same thing we are going to do. Everything zeros. We are going to paste the endpoint for this one as well. Okay, it won't let me pick again. What was it? This is the endpoint, and I think it is 86. Save changes, route tables. Let's go pick this one. Routes, edit routes, route that everything that comes to this one, and I think it is this one. Save it. That's for the transit gateway subnet A and subnet B. Okay, cool. So I think pretty much we created all of that. Now let's go to transit gateway route tables. Even transit gateway has its own route tables. Okay, so here we have two of them. One is for the normal one, another one is for the firewall. Let's click the route table. Okay, and then let's click routes. Okay, and here we are going to create static route, and the cedar range is going to be this, and we are going to say active. We are not going to block, we are going to allow, and the attachment we are going to choose is the egress transit gateway. Okay, now if I select this one, routes, okay, it's not explaining, but okay. And same thing, let's go do this for this one, routes, create. Okay, now for this one we are going to choose the VPC As, because this is for the network firewall, right? So we are going to choose the A1, and then we are going to choose active again. It's going to be A, the attachment. Anything that comes to the A should go to the A1, A attachment, right? Because this cedar block belongs to VPC A. Any IP address that we need to send it to that one. That's why we are selecting this one. And same thing, it has to go through firewall route. That's why. And same thing, we are going to create another static. And this, I think, what is the cedar for the B one? I think it is this one. This. So anything that comes to this VPC cedar block, this belongs to B. So we have to send it to B. Create the static route. Okay, now we have those two. And if I click routes, it should show those. Why is it only showing one? What is this? Is this the one that did I just create it? No, I didn't create that. Oh, it is showing now. Never mind. Okay, we have those. Now let's go back to our this one. Oh, it's gone. That's fine. Let's go here, here, connect, connect. It didn't save that. Okay, never mind. So let's get the Amazon command, paste it. If we did everything right, then this should work. Looks like it is working. Cancel it. And if we try to do that for the Google, it won't work because we didn't add a Google in the domain list. Okay. As you can see, connection timed out, closing. Okay, now in order to handle that, what did we do previously? We went to the domain list. Okay, I think it is a rules group. I think it's not here, right? Okay, I think it is here. Firewall, not DNS firewall. I think we did DNS firewall in one of the project. I think that's where I was getting confused. Edit. Then let's type dot google.com. Save it. Now if I do this, okay, let's give it some time. I mean, it's immediate, but come on, not that immediate. As you can see, it is working successfully. Okay. Now to test the ICMP, let's ping this one and it should get blocked. Oh, it is pinging. Sorry, it should get pinged, I guess. Did we allow that? Is that one? Let me see. Did it work for them as well? Or did it fail? Oh yeah, it did work for them. Look, ICMP, we enabled it. We didn't block it. Okay, good. Now let's go to the CloudWatch. I think I have to rewatch this video several times to understand what they are trying to do because I know, but I won't remember this. Okay, I think we have only this one. You can see blocked, not matching that one from this IP address or whatever it is. Network firewall, google.com, the initial one. And if you go to the flow group, log group, they didn't have anything. Why? That is weird. Hmm, that's okay. All right, I think we anyway successfully did it, I guess, even though like there are so many things involved, maybe I don't understand the entire process. I think I just followed whatever they told me to do. I think I will revisit this one more time. If you understood it, try to explain me in a clear way. Update the route tables for VPC be egress to allow default routes to the transit gateway. Add a route for the lab cedar block in. Yeah. So whatever we did, I think we did it for VPC-A, and if we were to connect it to VPC-B, oh, not this one. Where is that? Oh, it closed it. Okay. Yeah, as you can see, connecting timeout for Google. You might be like, oh, we add it in the domain? Yeah, but we didn't set up for the VPC-B at all. So far, we did it everything for VPC-A. So for DIY, they are asking us to do that. So, so let's go figure this out. Okay, first thing we did after establishing the firewall is we went to route tables and we added everything for A. So let's go here, routes, edit routes, and add route. And we said, I don't think we said everything that comes to um, zeros. Did we say everything that comes to zeros should come to, let me think. Yeah, I think everything that comes. And I think we picked the sorry, the transit gateway. Yeah, and we said go to the VPCB obviously for this one. VPCA we said that, but VPCB we didn't. So everything that comes out of VPCB has to go through the transit gateway, which is going now. So that I remember doing it. And what else did we do? Then they're saying VPC egress to allow default routes to transit gateway. Huh. I think we already did this for all these ones, right? We already, yeah, lab, we already did this for all of them. So I think this should be fine. Add a route for the lab VPC B CIDR block in transit gateway firewall right table. Okay, now once this is done, we should go to network firewall, not network firewall, transit gateway route tables. I think even here we might have done it. Firewall route table, right? We added both, right? Yeah, we added for both. So we are fine that. And then verify connected. Oh, okay. I think that's all it is missing, huh? Okay, it is working. Yay! Oh, that was fast. We did most of that way before. Okay, it's just network firewall. I don't know what they're going to check to validate this one. Cannot find to egress target gateway attachment in firewall subnet B route table. Is that so? Okay, where is the route table? Egress firewall subnet B. Did we not do this here? Oh, we didn't do it here. Okay, never mind. I don't know. How did we miss that? That's weird. Is this a firewall one? Yeah. Okay. So here we picked and we said everything. It doesn't matter. /8. It will go through all three subnets. And here I think we said this has to go to the transit gateway and the VPC egress attachments. I guess that's what we did, right? Because we are firewall, right? Yeah, okay. After it goes to firewall, we are sending it to the other transit gateway. I guess that's what it is we are doing there. Yes. Okay, I know I'm saying yes, like I understood something, but anyways, I think this is what is happening, right? Let's see if I can get the diagram again. Okay, this is private, both completely private, but both these availability zone A and B, these are B2 have, there are two of them that are public. So when you have public, you have to have a firewall endpoint created. That's why we are creating in here, not in here. Okay, because we have public here and there is internet gateway connectivity going on these two. That's why we selected this so that we can talk privately to others. Now, transit gateway, when you create it, since we have three VPCs, 1, 2, and 3, in order for them to talk to each other, what will we do? We create attachments in the transit gateway, and each one will have its own attachment. Each attachment will have a CIDR block range. Let me show you that one. What? Okay, here we go. Okay, if I pick A, or if I click, let's say click, because this is something that we already did it as part of something else, I guess. It's asking the transit gateway. Yeah, that is the transit gateway, and the attachment type is going to be VPC. In the next project, you will pick peering connection because we will peer to transit gateways anyways. And here you are going to pick the VPC ID, and we are going to say like, okay, this is the CIDR or VPC that I am going to attach. And then you have to pick at least one subnet ID, and we only have one subnet ID, so we are picking that. If you see here, only one subnet we have, which is in the zone A. This is for the zone B. So basically attachment is that, we are just attaching this particular VPC to the transit gateway using attachments. And there are three attachments like that we have to create for each one of these VPCs. Okay, so far I think that's good, and I think it was even made sense for me to even have this firewall rule groups, policies, and firewalls. No problem there. But the most confusion that I had was in the routes when we were in the normal route table, VPC route table, wherein we have the the routes tables for all these that are created, all for all the subnets that are created. So first one, the VPC A workload, I think what we did is we went ahead and added this, or not this one, this one. So here what we are saying is whenever some traffic that comes to this particular subnet, right? Um, and we are saying anything that comes, and if it goes, then send it to this transit gateway, right? Because it is A is what our EC2 instance. It can try to reach out to, from here it can try to reach out to this one. Okay, so that's why we are saying anytime you try to reach out to from here to anything else, destination 000 means any IP address, send it to the transit gateway, right? That is what we are doing here. Send it to transit gateway, VPC-A transit gateway attachment, right? So transit gateway, there is an attachment that is joined to this one. So we are telling send it to that one. Same thing we did for B. Anything from here, any IP address, if you are going to send it to the transit gateway because this will take care of it. Then the transit gateway route table will figure out, oh, okay, then it has to go to this one. It has to go to that one. Okay. Anyway, so that is this particular route table we did. in this one, and then we did the similar one for B, so no brainers. Then we have separate subnets for the firewall, sorry, route tables for the firewall, and separate for the public, and as well as separate subnets for the transit gateways. Okay, if we go here, okay, that's fine. So in this, what did we do for this firewall subnets? We went ahead and added this one. It already had a NAT and this one, but when you give this CIDR, this consists all three CIDR blocks. It consists the IPs in this one, this one, this one. Okay, 000. Okay, so it consists IPs of all. So anything that tries to go to those one of those IPs, it is sending it to the transit gateway. And if you see which transit gateway is that, the VPC egress. Okay, and that is for A, and for B, which is similar. So I don't have to show that there. And then we did the public, and here the difference is we went ahead and anything we said take it through the endpoint, the endpoints we have, because these are like public subnets, both of them. And then the transit gateways, and we went ahead and said the same thing for them as well. Anything that comes their way, uh, sent it to the what, the endpoints, both of them. I think here I have some confusion why we had to pick all zeros here. Anything, maybe transit gateway we have to, and here when we say public subnet A, we are only using this particular notation. So I don't know the clarity on that, but anyways, so that is the route tables. Then we went ahead in the transit gateway route tables, and again we have two of them. One is the transit gateway table and the firewall route table. And in this one we have this, we are sending it to the transit gateway attachments. And then for the firewall, for each one of them, we are sending it to the respective ones. I think I have to again go through multiple times to understand it. I hope it made sense for you. At least I am assuming. But for me, I think I have to go through multiple times. So let me close this once. All right, we finished it. Let's give the good news. This works like a charm. We can filter outbound traffic using network firewall. Choose a reward. So let's click on connect. Okay, let me move this aside because I almost clicked on the reset the recording. Okay, it's time for fireworks. I hope, I know this is a long video and too many things to go. Even my head is hurting, so I will go and have some tea, but we still need to do the quiz. I hope you enjoyed this, and you know what to do. Click on those like, subscribe, share, and comment. Definitely comment for this one. Okay, let's stop this and let's go do the quiz and let's see who is going to win this one. Did I miss? Network firewall supports only stateful rules. No, we clearly saw there are stateless as well. Okay, 1-0. And again, don't copy answers from me. Pause the video and then do your answer and then check what I'm answering. So pause it right now. Which resources are essential to AWS network firewall? Um, Definitely roles, definitely VPC. It's not transit gateway. It has nothing to do with network firewall. Internet gateway, I don't think so. Security groups, I hmm, I don't know. I don't think we selected that. So we created the groups and then we created the policy. Then we created that. So which resources? I will pick this one. Let's check this one though. Okay, VPC. Oh, internet gateway as well. But where? Hmm. Maybe. Okay. This I will make it as wrong because one option is wrong. So what was it? 1-1 so far. If you answered correctly, you can mark it as 2-0. Up to you, whatever you did. Mine is 1-1. Traffic in appliance mode is routed correctly as long as the source and destination traffic are coming to a centralized VPC from the same transit gateway attachment. I don't know this is what this is. I will just pick true though. I don't know. I think I need to go through these diagrams to understand what exactly they are doing. Okay, I still don't understand this one. Hmm. I will select true if it is not true. I will know if it would be false. Hey, it is correct. So 2-1. Oops, I missed it. How does AWS firewall, network firewall achieve fault tolerance and availability? High availability, always multiple availability zones. Okay, how much? 3-1? Yeah. What are the supported log destinations? Oh, this should be easy. It's this one, this one, this one. 4-1. I think that's about it. I think they only ask 5 questions, right? If I'm not wrong. I didn't realize that they will only ask 5 questions until recently. So after doing 60 projects. Yeah, I think they will only ask 5 questions. It is 4-1. I think this question will be a different one. Yep. By default, S3 versioning is enabled on buckets and it must be explicit. No, it's false. Oh no, what? Versioning is enabled by default? I don't think so. Which type of IAM policy requires a principal to be defined? This one. What was it? We did it. Either I don't know. I think yeah, it's identity. No, it's not identity. It is resource. This is the second time I did it. So I would say 4-3 because those two are wrong for me. It doesn't matter. 4-3. I think I'm going to lose this to all of you. So do leave your score in the comments and don't forget to put my score as well because I won't be remembering my score by the time this goes live. So put my score as 4-3 and put your scores. Let's see who won, who all won, who is paying attention to this video and who is not paying attention like me. Anyways, thank you very much for your time. See you in the next one. Have a great day. Peace out.